All right, so question number 1 is to write a chemical equation in which hydrobromic acid is reacted with rubidium hydroxide, and then identify and label and name the salt, or identify / label. That means kind of the same thing in that case. Okay. So hydrobromic acid. Hydro, the prefix hydro, means that you have a binary acid that is only 2 elements. All acids have hydrogen in the front, have at least 1 hydrogen, could have more than that. Bromo means I have a bromine on the backside. Okay? Bromine in a binary compound has a 1 negative charge, and the acidic hydrogen has a 1 plus charge, so I need 1 of each, and that's the balance for that formula. I'm going to put that together with rubidium hydroxide. Rubidium is not a polyatomic ion, it is an element. You find it on the periodic table, and that's Rb. In a compound, it has a 1 plus charge. Hydroxide is a polyatomic ion, and that's OH. Rubidium has a 1 plus charge. Hydroxide has a 1 negative charge. So I need 1 of these and 1 of these. Since we're going to react them together in an acid-base equation, yesterday I told you that you always do that in water. I probably won't count the aqueous part, but for the future, you need to know that you always, if we're going to react acids and bases, we're going to do it in water. Okay? Yes.
I thought that the thing says oxides are insoluble.
Yes, but this is not an oxide. This is a hydroxide. Okay? All right. So 1H, 1Br plus 1Rb and 1 hydroxide, and then the arrow. That's what we got points for so far. 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4. Yep. All right. Then an acid-base reaction for Arrhenius acid bases, and these are Arrhenius acid bases. We've got hydrogens on the front here that can come off, hydroxides on the back that can come off, or double replacement reaction. And so this hydrogen is going to join up with the back of this. H goes with OH. H is 1 plus, OH is 1 negative. That's balanced. You should be able to recognize by now that that's water. So in an acid-base reaction, we list that as being a liquid. The front part of this is going to go with the back part of this. Rubidium, bromine, a bromide. Rubidium, we said a moment ago, was 1 plus. Bromine's 1 negative in a binary compound. If you look it up on your solubility rules, you'll find that bromides, chlorides, bromides, and iodides are all soluble. So we're in water, they will be soluble unless we're bonding them with silver, lead, or mercury, and that's not one of those. So this is going to be aqueous. Okay? So we got this, the front part and the back part, and, well, yeah, you should know the physical state here, plus rubidium bromide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points total for this question. Wait, now I haven't finished. I got to identify and name the salt. The salt is the product of an Arrhenius acid-base reaction other than water. This is the water. This is the other than water. So this is the salt, and the name of this is rubidium bromide. Okay. Let's give the identification of the salt 2 points, and the name 1, 2, 3 points. Brom, BR on the front gets a point, and the IDE gets a point.
Well, they didn't put salt, but they put the name under the. I mean, they knew it was a salt.
But did they say it was a salt?
It isn't salt.
Well, how did they identify it as a salt?
Well,
if they didn't identify it as a salt, they don't get those 2 points. And so that comes out to be 15 points total, right? Number 2 on the quiz. Identify label/identify the strong acids below and explain how you know them to be strong. Okay? The strong acids are B, H2SO4, E, HCl, and F, HI. Did I miscount it?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You're right, 17 points.
It's Friday.
Yeah, it's Friday. That's my excuse today. All right, 17 points for number 1. All right, these are the strong acids. Identifying them correctly is each worth 1 point, but it doesn't say you can only identify them. It says you have to explain how you know them to be strong. Okay? Now, there are 2 ways to know that they're strong. One is to identify them as strong from memorization. You could say, I memorized them. Okay? The other way,
I should have done that.
Oh, I was writing out.
the other way is to say that there are 2 or more oxygens than hydrogens. Actually, it's acidic hydrogens. I'm just shorthanding it here, okay?
Okay, so those are all weak or strong?
These are all the strong acids. It only asks you to identify the strong acids.
Awkward.
Okay? We're going to get to counting off points for identifying weak acids incorrectly in a minute.
What I did is, I just did similar, but like I left them all like in a line, and then I wrote down like
An explanation.
yeah, like
All of them.
That's fine. As long as you identify the strong acids, I don't care. All right? Now, HCl is a strong acid because the anion, which is chloride, you don't have to say it that way, but the anion is one of the middle halogens. Again, you can say you just memorized it, but if you that's okay, or you can say the anion is one of the middle halogens. And the same for the last one, the same thing. And what I mean by middle halogens, when I find where I put the periodic table, is that this column of elements, the next to the last one on the right, are the halogens, and the ones in the middle, these 3 right here in the middle, if they are acid anions in a binary acid, and only in a binary acid, then that makes the acid strong. Okay? Now, so each of these explanations is worth a point. All right?
So then you have to put anything for the other?
For the, it doesn't say identify the weak acids.
Oh, okay.
Okay, now, if the student stated that one of the other 3 acids was strong, count off 2 points. So you're getting 2 points for the identification and the reason. If they identify incorrectly one of the weak acids, you count off those 2 points. You lose those points.
Negative points on my
Well, you can't have anything lower than a 0. All right.